Welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. How are you all? How are you all? Everybody in the chat box. Very good evening to everyone here. So guys, today we are going to do a very short and crisp lecture on organic reactions, organic chemistry conversions, okay? So in this way, you will be able to recall the conversions in different perspective, okay? So, you know, what's the best way of revision? The best way of revision, especially organic reactions, is by doing the conversions, okay? Usually NEET students, this is for CBSE as well. Firstly, I think I've been seeing this in the chat box. Is ma'am, this is for CBSE or this is for NEET? This is for both CBSE and NEET. In CBSE, these questions are asked directly, and in NEET, these questions are asked indirectly. So for both the students, these kind of question, to practice these kind of question is very important, and this is going to boost your organic chemistry. Like if you are here at organic chemistry and you are not able to recall the reactions, by practicing organic chemistry this way, you will be able to retrieve the information whenever you are in the exam hall under the pressure. Okay, so everybody, are you all ready? Everyone in the chat box, are you all ready? Everybody in the chat box, what's the best way of... Wait. So everybody in the chat box, are you all ready or not? Yes. Ready, bacha? Everybody in the chat box, I want all of you to answer this. Are you all ready or not? I want green hearts in the chat box. Everyone. Yes. Take this. Okay, bacha. Don't worry, bacha. Don't worry. We will do that. Okay, we will do that. Okay, so everybody, I want green hearts in the chat box. Okay. I want green hearts in the chat box. Green chemistry, organic chemistry, green chemistry. Yes, everybody. So that we can start the session. You know what? Now we are going to organic chemistry. We have completed organic chemistry. On Thursday, we are going to do biomolecules. So after that, I'm not going to say, okay, you can practice the organic chemistry yourself. Yes, definitely you have to practice the organic chemistry yourself. But also while we are doing physical chemistry, we will revise the organic chemistry by doing flow charts, conversions, difficult questions of organic chemistry, tricky questions of organic chemistry. All those things we will do side by side. Okay, guys? Yes, perfect. Okay, everybody. So let us start the session. Everybody, I want all of you to grab your pen and notebook and write it down along with me, and practice that along with me. So let us start the session. The very first conversion here is pent 1-ene to 1-idopentane. Okay, we have 1, 2, 3. Everybody in the chat box, I want all of you to answer these, okay? I want all of you to at least try to answer these questions. So let us see, this is pent 1-ene, okay? This is 1, 2, 3, 4, 5. Pent 1-ene, that means here it should be ene, okay? I'm not applying any hydrogen, okay? You can just directly write hydrogen by completing the tetravalency of carbon. You can do that yourself, right? Okay, this is pent 1-ene and this is 1-ido, 1, 2, 3, 4, 5. This is 1-idopentane. Okay. So how we are going to do this? Anybody? Anybody in the chat box? Anybody in the chat box? Bacha, how we are going to do that? Bacha, this is for both for 11th, 12th. This is for 11th. If you have 11th, only those students who have completed the 12th organic chemistry part. Okay. So this is for 11th. This is for 12th. This is for droppers. Anyone who is preparing for any chemistry exam. Okay. Now everybody in the chat box. Yes. Okay. How are you going to convert this into ido-alkane? For ido-alkane, bacha, very good, Sanjana. Firstly, what we are going to do here? Firstly, we are going to do anti-Markovnikov rule. That means anti-Markovnikov rule is applied on HBr, right? Okay. So this is HBr, and we are going to add peroxide for anti-Markovnikov addition. Okay, for anti-Markovnikov addition. Okay, and what we are going to get from this one? That is negative part. The negative part here is this, and this is the positive part. The negative part on more number of hydrogens. More number of hydrogens, bacha. Let's just complete the valency here. This is H2 and this is going to be one hydrogen only. Okay, so more number of hydrogen are on this carbon. So this is going to be CH. I'm writing it here. This is going to be CH2. This is Br. This is CH2. This is CC. You can write it CH2, CH2, CH3. Okay. Now, to convert a haloalkane and the halogen there should be chlorine or bromine into ido. What we do? What's the name of this reaction? This reaction is called, what's the name of this reaction? What I add here? I add NaI and acetone. And what is the name of this reaction, everybody? What is the name of this reaction? This is nothing but Finkelstein reaction. Okay, this is Finkelstein reaction. Okay, just write it down, Finkelstein reaction, and you will have your desired product, that is 1-idopentane. Yes, perfect. Okay, now the next conversion here, second conversion here, everybody. Second conversion is chlorobenzene to biphenyl. Okay, chlorobenzene. Okay, let us draw chlorobenzene. Chlorobenzene is this one. This is chlorobenzene. We have to convert it into biphenyl. Biphenyl means there are two phenyl rings here that are joined together. This is biphenyl. So convert chlorobenzene into biphenyl. Anybody in the chat box? Very simple reaction. A very important naming reaction. How can you convert chlorobenzene into biphenyl? Everybody, yes, be active. Very good, bacha. Thank you, bacha. Thank you. I just want all of you to study hard. That's it. Okay, that is my, Guru Dakshina. If you can understand what is Guru Dakshina, it is like what you give your teacher, like the knowledge that they are giving you, what you give in return. You give in return your love, your support, your efforts, right? Your hard work. This is all what we want, right? So we are going to do what here? This is Fittig reaction, very nice, very good. Fittig reaction, that is 2 sodium, right? 2 sodium. This is Fittig reaction. In presence of dry ether. Okay, this is in presence of dry ether. Because sodium is very reactive metal, right? Okay, so that is why dry ether is used here, right? Ether is for solvation energy, and dry ether because sodium is very reactive in moisture. That is the reason we use dry ether. Okay, this will convert it into aryl and aride. Okay, that is Fittig reaction. Okay, perfect. Thank you, bacha. Thank you. There's so much love that you give us, na. Don't worry, na. So because of this much love that you have given me, the kind of acceptance that you have given me, for that I am coming up with lots of things in coming 2 months. So many things for you. So be ready for all of that, right? So this is 2-bromobutane, everyone. 2-bromobutane to butene. Okay, 2-bromobutane. This is everybody here. 1, 2, 3, 4, and this is 2-bromo. Okay, this is 2-bromo means here this is CH3 and this is going to be CH2, CH3, right? This is 2-bromobutane to butene. What is butene, anybody? Butene, everybody in the chat box. What is butene? Yes, butene is 1, 2, 3, 4 and 2ene. That means here. Okay, this is CH3, this is CH3. Yes, everybody in the chat box, I want all of you to answer these questions. Okay, so this is 2-bromobutane to butene. Yes, what can we do here? This is 2-bromo, so this is bromine here, we have alkane here, and we need to convert it into alkene, right? We need to convert. This is a very simple reaction, very simple. Okay, this is dehydrohalogenation by Sedzeff rule, right? By Sedzeff rule. So what is the reagent here? Everybody? What is the reagent here? This will be the major product by Sedzeff rule. by Sedzif rule, right? Okay. So this is nothing but dehydrohalogenation. Okay, dehydrohalogenation, right? And here this is done by anybody. What is the reagent here? What is the reagent? Everybody in the chat box, what is the reagent? Very good, very good. Orders like reactivity order. Bacha, Dr. Apollo, we are going to do that. Okay, like today I have conducted one session specially for your conversion, and similarly I am going to conduct so many sessions like this, like on distinguished test, all the distinguished tests, and like all the reagents. All these are coming up for you. Okay, that are in the way, that are on the way, right? Okay, don't worry about that. Okay, so we'll discuss all the orders and reactivity orders, right? Okay, so this is alcoholic KOH. This is alcoholic KOH. Alcoholic KOH is responsible for the dehydrohalogenation, and this is going to be the major product according to hyperconjugation. Okay, hyperconjugation. Hyperconjugation, more the number of alpha hydrogens, more is the more stable alkene is formed. More the number of alpha hydrogen. Right? That is why bromine from here and this from here. We cannot form this one. Okay? If you say from this, ma'am, we can also form this product. That is this one. Right? Here, the alkene will be, 1, 2, 3, 4, and this is H, and this is CH2, and this is CH3. Here the alpha hydrogens are, two alpha hydrogens. So this is the main product, this is the main product, and these are the alpha hydrogen. That is 2 alpha hydrogen. Here the alpha hydrogens are, this is the main product, and these are the alpha hydrogens. So 6 alpha hydrogens here. So this is going to be the major product here, right? Okay, perfect. Till now any problem, bacha? Till now any problem, right? Okay, perfect. Next is 2 bromopropane to 1 bromopropane. 2 bromopropane. Everybody. Now you have 2 bromopropane. Okay. This is 1, 2, 3, 2 bromopropane. This is CH3, CH3. This is CH. Okay. Let us write here CH. This is CH3. Okay. Here 1 bromopropane. 1 bromopropane is nothing but this is CH2Br and this is CH2CH3. Okay, how do we convert this into this? Everybody, how can we convert this into this? How can we convert this? Everybody in the chat box. How can we convert this? Now, this is 2 to 3 step, okay? This is 2 to 3 steps. We can directly add something and convert it into 1 bromopropane. Firstly, can we do a thing? We can convert it into alkene. Then we can convert it into 1 bromo, right? We can do the dehydrohalogenation here, and after that we can add the HBr by anti-Markovnikov rule, right? HBr by anti-Markovnikov rule, right? Halogen dehydro, very good, bacha. So this is nothing but, firstly we have to do the dehydrohalogenation. That is alcoholic KOH, and here we are going to add this one. Here we are going to add this one. That is CH3. This is CH. This is double bond CH2. Right. After that, we are going to add here HBr in presence of peroxide. And here it will be anti-Markovnikov rule. Here it will be anti-Markovnikov rule, and we will get the desired product here. Okay, and we are going to get the desired product here. Right, everyone? Yes. But the spellings can be wrong here. It is also written as this one. Okay. The spellings can be wrong. I am not so good with the spellings, right? It is also written as this one. Okay, it is also written as this one. It is pronounced as Sedzif rule, and it is also written as SCT. Okay, so that is the rule, right? Sedzif rule. Okay. Yes. Okay. Less number of hydrogen. No, bacha. No. This is anti-Markovnikov rule. So here, negative part will be on the more number of hydrogen. Okay, this is anti-Markovnikov. That is only applied to HBr. Okay, if they have written here chloro, then we can't do it by adding the peroxide, because for HCl. It does not follow anti-Markovnikov rule for peroxide addition, right? Okay. Next is fifth one. Here we have aniline. Okay, we have aniline. Perfect. We have aniline. Wow, we have aniline. Okay, Anil bhaiya. Okay, then we have fluorobenzene. Okay, this is fluorobenzene here. Right, this is fluorobenzene here. Everybody in the chat box, very simple reaction. Yes, tell me, I want all of you to answer this, okay? If you're trying to answer in that way, you will be able to recall that what you have studied till now. All the things, all the reactions that you have studied till now, you will be able to recall those reactions, okay? So this is aniline. You have to convert it into fluorobenzene. That means this one. So how can we convert something into fluorobenzene? We know that one reaction, that is Ball-Schiemann reaction. Yes, very good. Very good, bacha. Very good, Sanvi. We know one reaction, that is Ball-Schiemann reaction. What is Ball-Schiemann reaction, everyone? What is Ball-Schiemann reaction? Ball-Schiemann reaction. In this reaction, what we do? We add HbF4 and heat it. And what is the reagent here? What is the reactant here? The reactant, the starting product is disonium salt here. And how do we convert aniline to disonium salt? How do we? Always see these processes in reverse, okay? First you have to go fluoro. That is only possible by disonium salt, okay? How do we convert aniline to disonium salt? Simply by Na diazotization, that is NaNO2 plus HCl, then 0 to 5 degree Celsius, right? This is the disonium salt that is formed here, right? Then we do Ball-Schiemann reaction where we add HbF4 heated, we can convert it into fluorobenzene, okay? Perfect? Yes. Next is chloroethane, okay? Next is chloroethane. You have this CH2, CH3, this is Cl, right? This is chloroethane. Next is butane, CH3, CH2, CH2, CH3. Always remember one thing. When we have, this is 2 carbon atoms in the reactant and here we have 4 carbon atoms. That means this is actually double the carbon atoms. That is only possible in few cases, okay? And here the few case will be, we have a halide here, right? We have a halide here and we are converting into double the number of alkene. That is possible. Very good. That is possible by Wurtz reaction. Okay. So what we are going to do here, everybody, what we are going to do here, we are going to add, or you can directly write it here, This is dry ether. This is dry ether. And here, this is plus 2Na, and we will get, this is the Wurtz reaction. Okay. What is the name of this reaction? This is Wurtz reaction. This is Wurtz reaction. Okay, perfect. Yes, yes, very good, very good. Next is phenol to salicylaldehyde. Phenol to salicylaldehyde. Okay, you have phenol. Okay, you have phenol. Everybody, very simple reaction, very important naming reaction. You have phenol. You're going to convert it into salicylaldehyde. Okay, salicylaldehyde they are talking about. Okay, what is the name of this reaction? You have phenol. You are going to convert it into salicylaldehyde, that is, this is OH and this is CHO. Now what is the name of this reaction? When we have salicylaldehyde, in that case, what is the answer? Everybody in the chat box. Very good, very good, very good, very good, very good. Okay. Right. So here the reaction name is Reimer-Tiemer reaction, okay? And what are the reagents here? What are the reagents here, everybody? This is Reimer-Tiemer reaction. This is Reimer-Tiemer reaction. Reimer-Tiemer reaction. And what are the reagents here? The reagents here are CHCl3, KOH, right? Then we have hydrolysis, right? These are the reagents here. Yes, everybody? Yes? Okay? Also one thing, what is the intermediate here? What is the intermediate here? Everybody, what is the intermediate here? I want all of you to remember this. Intermediate in dimer-dimer reaction is very important, right? Okay, what is the intermediate here? That is dichlorocarbene, okay? Dichlorocarbene, that is acting as an electrophile. It is CCl2, right? This is basically electron deficient. It is acting as an electrophile because the electron are not, the octet of carbon is not completed here. It has just 6 electrons, right? Okay, perfect. Now, if they have written that you need to convert phenol into salicylic acid, okay? Phenol into salicylic acid. Everybody, what will be the reagents here? Okay, there are 2 ways to convert. There are 2 ways for this. Okay, we have 2 ways. What are these 2 ways? Okay, what are the 2 ways here? Right? So what are the 2 ways here? First is Reimer-Tiemer reaction. With CCl4, KOH and hydrolysis, right? This is with CCl4. Aldehyde was for with CHCl3, right? Or you can use Kolb's reaction, okay? Kolb's reaction, that was by CO2, right? CO2 KOH, right? And hydrolysis, right? Okay. Understood? Kolb's reaction, this is Reimer-Tiemer reaction. Very good. There are 2 ways. Next is phenol to benzoquinone. Now everybody, how can you convert phenol to, this is phenol. Now what is benzoquinone? Everybody in the chat box. What is benzoquinone? Yes. Okay. This is going to be benzoquinone. Okay, this is benzoquinone. Now, how you convert phenol to benzoquinone? It's a one-step reaction. This is a one-step reaction. Okay, one-step reaction. Very simple. Here we are going to do oxidation. Okay, oxidation by what? Everybody, oxidation by what? Very good. Na2Cr2O7. Very good. Na2Cr2O7. Right? H2SO4. Okay, or you can say directly H positive. Right? And then you will have your desired product. Right? Okay? That is benzoquinone. Very important reaction. Next is propane to propanol. You have propene, right? You have 1, 2, 3. You have propene here. This is CH, this is CH3, 1, 2, 3, 4, and this is, we are going to convert propene to propene, that is 1 we have E, right, to 2 propanol, 1, 2, 3, 2 propanol, okay, on the second position you have ol here, this is CH3, this is CH3, and this is going to be CH, this is CH3, right, okay. Now convert this. Now everybody convert this. How you are going to convert these reactions? How you are going to convert propene to alcohol? Everybody, now remember this. Here we are actually adding water. Right? We are adding water here. Right? We are adding water, and this is via this, we can do this by 2 things, okay? We are adding negative part to less number of hydrogens, okay? Or we can say more stable carbene is formed here, okay? Yes. So we can say we are doing the acidic catalyzed hydrolysis here, right? Okay, yes, we can do this just by this one, or we can this by oxymercuration demercuration, okay? Oxymercuration demercuration. Now you have three ways of adding OH, right? You have three ways. First way is by adding H positive, acidic hydrolysis. Second way is hydroboration oxidation, oxidation, right? Third is oxymercuration, demercuration, right? You have these things. Now here, very important thing here, acid catalyzed hydrolysis, you have rearrangement of carbocation. Hydroboration oxidation, here you have anti-Markovnikov rule, right? And oxymercuration, demercuration, you have Markovnikov rule. Okay, you have Markovnikov rule. Okay, sometimes, only sometimes, you have same product for acid catalyzed and oxymercuration, demercuration. But this is the exact method by how you do this. Okay, this is the exact method. Okay, everybody? Yes, perfect, beta. Understood this? Now let us come to the 10th reaction, that is benzene to phenol. Everybody, benzene to phenol. You have, this is benzene. Let us convert it into phenol. Yes, everybody. Benzene to phenol. How you are going to convert benzene to phenol? Very simple reaction. Benzene to phenol. Okay, everybody. Benzene to phenol. Yes, everyone. Benzene to phenol. Yes, everyone here. Think about this. Let us convert benzene to phenol. Okay? Let us convert benzene to phenol. Now this is going to be so many steps here, right? Okay? How can you convert it? Okay? To disonium, then H2SO4, perfect. Always remember, there can be so many methods from going to one position to other. Okay? From going to reactants to products, there can never be only one way. There may be one way only. There may be so many ways. It totally depends on reaction to reaction. Okay? Okay? So now, first is how I am going to do it. Everybody, how I am going to do it. Firstly, I am going to convert this benzo. Okay. Now, I know for making phenol, I have so many ways of making phenol. Very nice. You can do the diazotization. Very nice. There are so many ways of doing this. You can convert it into N2Cl, then convert it, then warm it. Like you can convert it into aniline. Then convert it into there are so many ways. You can convert it into nitrobenzene, then to aniline. Okay, you can do one step here, that is nitrobenzene here, then reduce it to aniline, then reduce it to disonium salt, that is N2Cl, then convert it into phenol here, by warming it, right? This can be first way. The second way can be, you can convert it into cumene, that is CH3, right? And then you can convert it into, then you can add O2 here, then convert it into, this will be CH3, then OOH here, then you need to hydrolyze it, and then you will have the acetone and phenol here, right? There are so many other ways also. You can convert it into chlorobenzene here. Right? Then convert it into phenol by Dow's process. Right? There are so many ways, and all the ways are correct here. Right, everybody? Okay? Everybody? Yes? There are so many ways. You can convert it into, you can react this with oleum, right? And after that, convert it into phenol. There are so many ways. Okay? These are the most important 3 ways of converting benzene to phenol. Next is propane 1 mole, that is propane 2-ol to propanol. Propane 2-ol to propanol. Everybody in the chat box, propane 2-ol, that is 1. Everybody, propane 1, 2, 3, 2-ol to propanol. Right? 1, 2, 3, this one. Now tell me how you can do this. Very simple. You have 2 degree. You have 2 degree alcohol. You have 2 degree alcohol, right? You have 2 degree alcohol here. To convert 2 degree alcohol to acetone. To acetone. This is acetone, right? Okay. What you need to do? You need to oxidize it, right? And we cannot use, we can use 2-3 things here, okay? We can use copper at 300 degrees Celsius, right? We can use PCC, any mild oxidizing agent, okay? Like PCC, PDC, all that. Okay, you can do this by converting that 2 degree to this one, right? Okay, everybody. Yes, bacha, done. No, by Grignard reagent, no. But with Grignard reagent, we need to add something here, right? Okay, no. We cannot do this by adding Grignard reagent. How you are saying by Grignard reagent? I think that is not possible. Grignard reagent, we will add one more carbon here. Okay, we will add one more carbon here. But this is not any chapter. This is general. Okay, this is general. Now next is ethanol to propanol. Okay, you have 1, 2 CHO here, right? This is CH3, C double bond O, and this is H, and this is propane 2-ol, right? This is 1 CH3, CH2, CH3, right? This is propane 2-ol. Everybody in the chat box, how you can convert this? Everybody in the chat box. Now, what we are doing here, everybody, always see what we are doing here, okay? We are actually adding one more carbon here. For adding one more carbon, the best way, if you have a double bond, if you have a carbonyl group here, if you have a carbon dioxide or any carbonyl group here, and you want to add one more carbon here, best way is adding Grignard reagent, that is CH3 MgX, okay? CH3 MgX in the presence of dry ether. Here what we will do? Here we will have, this is CH3, this is C, and this is going to attack here. These bonds are going to shift here. Then we will have OMgX here. This is negative, this is positive. And here we will have, this is H and this is CH3. Then we are going to hydrolyze it. And hence this will be converted into alcohol. Right? And hence you will have your desired product here. Right? Okay. CH3, CH3, and this is CH. Okay? Yes. Understood this? Okay, everybody. Now best way is to do this by adding Grignard reagent in presence of dry ether. Next is acetone to propane 2-ol. Okay, acetone to propane 2-ol. Everybody. Now we have acetone. This is CH3, C double bond, OCH3, and we are converted into 2-methyl. Why I am not writing this on the other corner? What's the issue with me? Okay, so this is propane, that is 2-methyl. Okay, this is 2-methyl CH3. Okay, propane 2-ol, and this is 2-ol. CH3, this is CH3. Now tell me how we are going to convert this into this one. We have acetone to propane 2-ol, 2-methyl propane 2-ol. Here also we have carbonyl group and we are adding one more carbon here, right? Same way we are going to add here CH3 MgX here in the presence of dry ether, and hence you will have your reaction, that is CH3C. This is going to attack on this side, right? And these electrons are going to jump here. O negative, MgX here. This is positive. This is CH3 and this is CH3. And hence we are going to hydrolyze it afterwards and you will get your desired product. This is, we have converted acetone to 2-methyl propanol. Okay? Very good. By adding Grignard's reagent here. By adding Grignard. These questions are asked so many times in your CBSE, in your NEET examination, in both the examination these questions are asked. Okay. Next is aniline. Next is aniline to phenol. Next is aniline to phenol here. Now we have aniline. This is aniline, okay? This is aniline converted into phenol. Everybody, very simple. How do we convert? We have just done that. We have just done this reaction, okay? Firstly, we will convert it into disonium salt, okay? Firstly, we will convert it into disonium salt, that is NaNO2 plus HCl at 0 to 5 degrees Celsius, and you will have your product, that is disonium salt. This is N2Cl, positive, negative. And then what we are going to convert, okay? Now you just need to warm it. Okay, add water and warm it. Add warm water here. Warm H2. That's it. And you will get converted. This will be get converted into phenol. Okay. N2Cl will be converted into OH. Right? Very good. Disonium salt, and after that just warm it. You will have your phenol here. Right? Next is we have phenol to, very important. Everybody, very important reaction. Now you have phenol. Now you have this phenol. Yes, I want all of you to answer this. You have this phenol and then you have para bromo anisole. Okay, that is OCH3. Now everybody in the chat box, how can you convert phenol to para bromo anisole? How can you convert? Okay, firstly we need to convert phenol to anisole. Okay, firstly we need to convert phenol to anisole. Okay, phenol to anisole. Everybody in the chat box, phenol to anisole. Yes, everybody. Yes, everyone in the chat box, how you can convert phenol to anisole. Phenol N2HCl, acetylation. That was NH2. Okay, we have to replace this OH with CH3. Okay. Yes, bacha. 2-bromo-3,3-dimethyl butane alcohol QH gives which product? 2-bromo-3,3-butane plus alcoholic QH. But I'll do that at the end of the session, okay? Okay? Yes, everybody? Nitration. Why am I adding nitration? What's the point of adding nitrogen here? Nitration, why, Mansi? We are saying bromo. Right? I'm saying bromo here. Okay. Firstly, just convert this into anisole by adding NaOH. Okay. By adding NaOH. Add NaOH here and you will have your anisole here. And then you add Br2 in presence of CS2 here. Okay. Br2 in presence of CS2 so that you get the para as the major product. Okay, you cannot add water here. You cannot add Br2 water. In that case, you will have tri product here. Right, here you add just Br2 CS2 here. Right, okay, yeah. Understood? Yes? Okay, cool. Now, next reaction is propanol to propane. You have propanol, that is 1, 2, 3 double bond to propane. This is 1, 2, 3. Okay, CH3, CH here, this is CH3. Very easy reaction, a very, very important naming reaction. You can do this with two methods here. You can do this with two methods here. Two methods here can be, first can be Clemensen reduction. First can be Clemensen reduction, right? Second can be Wolff-Kishner reduction. Wolff-Kishner reduction. Kishner reduction. In Clemensen reduction, you use zinc amalgam, right? In acidic conditions, right? Here you use hydrazine, ethylene glycol, and basic conditions, right? You can just write it here, basic conditions, right? Okay. So these are the two reactions where you can convert directly the carbonyl group to we can reduce the carbonyl group here, right? Okay, of aldehyde and ketones. Next is ethanol to everybody, very important. Ethanol to 1, 2, that is C double bond O, this is H, this is CH3, this is but 2, 1, 2, 3, 4, but 2-enal, this means C double bond O H here, this is CH here, and you have CH here, right? This is CH here, and this is CH3, right? Okay. So now this is, everybody in the chat box, what is this? Can you identify this? You have unsaturated. You have alpha beta unsaturated aldehyde here. Alpha beta unsaturated. Very good. This is aldol condensation. Aldol condensation. Right? Aldol condensation. Very simple. We are going to add dilute KOH here. Dilute KOH here. The two molecules will self aldol. Right? And what will be formed here? You have CH3, C double bond O. You have H. This is CH3, C double bond O. This is H. And here you have, this is the carbonyl group. This is the carbonyl group and this is the alpha carbon here. So what is the trick? What is the trick for aldol condensation? Just this is CH3, the carbonyl group of one molecule, add the alpha carbon of other molecule, and this is C double bond O, this is H, and then this will be one hydrogen more here, this will be CH, C double bond, and this will be CH. Yes, okay, this is going to be your answer, right? That is the desired product, okay? Understood? Yes, very good, very good, very good. So next is, very good bacha, next is phenol to toluene. Next is phenol to toluene. You have phenol to toluene, everybody. Next is phenol to toluene. Yes, everybody. You have phenol. You have phenol. Convert it into toluene. Convert it into toluene. Everybody in the chat box, what we are going to do here, right? You have phenol, convert it into toluene, right? Okay, convert it into toluene. Everybody, yes. How you can do this? Everybody, how you can do this? How to convert phenol to toluene? Yes? No, bacha, no. Etard reaction you have to convert this phenol to toluene. No. That is toluene to CHO. Okay, etard reaction is toluene to CHO. You convert this into benzaldehyde. Okay, that is etard's reaction. Okay, that is etard's reaction. One is saying etard, everybody else is saying etards. One is saying etards, everyone is like, yes ma'am, etards. Okay, this is not etard's reaction. No, this is not etard's reaction. Okay, this is not etard's reaction. Okay, etard's reaction is toluene to benzaldehyde. Okay, here no use of etard's reaction. You will convert it into benzene. You will convert it into benzene by adding what? By adding zinc dust here. And then convert it into any desired product. You will just add this will be Friedel-Crafts acylation, that is CH3, Cl, FAlCl3, and you will have the desired product, that is toluene. Yes? Okay? Done? Very good. Phenol to benzene, then toluene. Very good Nancy, very good. Next we have 2 degree alcohol to 3 degree alcohol. 2 degree alcohol to 3 degree alcohol. Now you have 1, 2, this is 2 degree alcohol. This is your 3 degree alcohol, right? This is your 3 degree alcohol here, right? This is 3 degree alcohol. Now this is CH2, CH2, this is CH3, CH3, this is CH, right? Okay. So now let us convert this, bacha. Let us convert this. This is 2 degree. This is 2 degree. You are going to convert it into 3 degree alcohol. What we are going to do, everyone? Now you can do one thing. You can firstly do the dehydration here, convert it into alkene, then apply anti-Markovnikov rule, right? Anti-Markovnikov rule means hydroboration oxidation. Yes, you can do that. Hydroboration oxidation. Yes, everybody. Yes, everybody. Everyone. Yes, everyone. Yes, everyone in the comment section. Yes. Okay. Yes. So what you can do here, you can convert, you can add H2SO4 here, right? It will be converted into alkene here, that is CH2 double bond CH, CH3, and then you can add anti-Markovnikov rule here, that is by anti-Markovnikov hydroboration oxidation, right? Hydroboration, that is diborane oxidation, peroxide, okay? Oxidation, right? That was B2H6THF and then H2O2, right? Okay, so these are going to be the conditions here. Okay, so you are going to convert it into this. Yes, OH will be on the mole number and we are going to convert it into this, right? For easy, you can also write it like this, okay? You can write it like this. CH3, CH double bond CH2, okay? One and the same thing, right? Okay, what is another method? We can also do this by one more method, okay? This can also be done by one more method. That method can be firstly, you can convert it into carbonyl. You can convert it into, no, I think this is the perfect method. I think this is much easier method, right? Okay, understood this? Wait, have I done something wrong here? 3 degree, okay. 2 degree to 3 degree, I have done something wrong here. I have converted it into, I have done something wrong here. I have converted 2 degree alcohol to, I have converted 2 degree to 1 degree here. 2 degree to 1 degree alcohol, right? And we have to convert into 3 degree alcohol. That was not this, that was this carbon, this CH3, this is OH and this is CH3. Now how to convert 2 degree to 3 degree? How to convert 2 degree to 3 degree? You can convert it into by adding anything like PCC or copper at 300 degrees Celsius, anything here. Convert it into ketone, right? Convert it into ketone, that is CH3, C double bond O, CH3. Then after converting to ketone, add Grignard reagent here, that is 3MgX here, right? That is 3CH3MgX and add water here. Now you will have your desired product, okay? You will have 3 degree alcohol here. Because this negative part is going to attack here, electrons are going to jump here, then you will do the hydrolysis and hence you will have 3 degree alcohol, right? Hence you will have 3 degree alcohol, right? Okay, next is ethine to ethanol, everyone. Next is ethine to ethanol. Yes, you will have CH, triple bond CH to ethanol. This is CH3, C double bond O. This is H. How to convert ethine to ethanol? How to convert ethine to ethanol? Okay, this is also not one step reaction. Okay, this is also not one step reaction. Okay, everyone, you have ethine to ethanol. Ethine to ethanol. What we are going to do here? We are going to add H2, water, H2, HgSO4. Okay, you will also need HgSO4, that is mercuric ions here for hydration of alkynes here. This is CH, break one pi bond here, add OH on the one carbon and H on the second carbon, and you have your enol here. You have enol, right? This is enol. Now tautomerize it. Now this will be tautomerized. Now there will be tautomerization, right? Tautomerization, and this is your 1, this is 1, this is 2, this is 3. Okay, the bond between 2 and 3 will be shifted to the bond between 2 and 3. Okay, if I write it here, this is CH2, this is CH, this is OH. Okay, so the bond between 2 and 3 will be shifted to 1 and 2, will be shifted to 1 and 2. This will be double bond O, and the hydrogen on the first will be shifted to hydrogen on the third, that is this one. Okay, that is equal to this. Okay, that is your aldehyde, ethanol, right? Okay, everyone? Yes, perfect. Adiposity gives enol and tautomerism, ethanol. Very good, very good. Next is acetone to propene. Acetone to propene. Now you have acetone, that is CH3, C double bond O, CH3. This is getting converted to propane, that is 1, 2, 3. You have this CH2, this is CH, this is CH3, right? Okay, how do we convert acetone to ethene? Acetone to ethene. Everybody in the chat box, how do we convert acetone to ethene? Yes, everyone. How do we convert acetone to propene? Yes, everybody. Okay. Acetone to this. So, firstly, if here we have alcohol, if we can convert this into alcohol, then we can do the dehydration here and convert it into alkene, right? Okay, right? So what we will do here, we'll do the reduction here, LiAlH4, right? Okay, so this will be converted to CH3COH, H, and this is CH3. Now again, this will be converted into, now this is going to be dehydration, there is going to be dehydration. For that you need concentrated H2SO4, right? For that you need, this is a very good dehydrating agent, okay? Very good dehydrating agent. Dehydrating agent, right? Okay? Dehydrating agent. Okay? Understood this? Everyone? Next is propyl benzene to propanoic acid, benzoic acid. Okay, you have propyl benzene. You have this propyl benzene, that is CH2, CH2, CH3. Okay, converted into benzoic acid. This is a one-step reaction. Okay, this is a one-step reaction. For any number of alkyl chain on the benzene, if you are reacting this with KMNO4, right, OH negative, then in that case, any chain here, whether it's ethyl, methyl, propyl, butyl, hexyl, heptyl, any number of chain, that will be getting converted into benzoic acid. Okay, understood? Yes, everyone? Perfect. Next we have 23rd, we are left with 7 more reactions, everyone. We are left with 7 more reactions, so let us do it fast. Benzoyl chloride. You have benzoyl chloride, that is COCl here. Converted into benzaldehyde. Converted into benzaldehyde. CHO. You have C double bond of Cl. Convert to C double bond of H. How do we convert Cl to H? Everyone. How do we convert Cl to H here? Yes, very good, very simple. That is Rosenmund reduction. Okay, Rosenmund reduction. And what is the, everyone? And what are the reagents for Rosenmund reduction? Okay, Rosenmund reduction. Rosenmund reduction. What are the reagents here? The reagents are going to be H2 catalyst and poisoned by BaSO4 or CaCO3 or or quinoline, okay, right, poisoned by this, right, to stop the reaction, to stop the reaction at this stage only, okay, right, because this reaction is very fast. This is acting as a poison here. Then we have propanoic acid to ethanoic acid. You have propanoic acid, CH3, CH2, C double bond OH to ethanoic acid. You have CH3, C double bond OH. Now, you need to reduce, right? You need to reduce one carbon here. You need to reduce one carbon here. How do we do it? And there are so many ways to do it, okay? There are so many ways. What I feel, what is the best way? Convert it into sodium salt, right? CH3, or you can simply write it here, soda lime decarboxylation, okay? Soda lime decarboxylation. Soda lime decarboxylation. Here you will get CH3, CH3, right? And then after that you can add here any what is the easy reaction on alkane, right? What is the easy reaction on alkane? Everyone, what is the easy reaction here? Right? What is the easy reaction? Fluorination, right, or bromination. Here you will convert it into CH3, CH2Cl. Right? Now you have CH, carbon number are same. Right? Then convert it into KOH. Right? KOH aqueous. Now you have CH3, CH2OH. Now this can be oxidized to carboxylic acid by adding KMnO4, right? Strong oxidizing agent. Yes, everyone? Okay, understood? Everyone here understood this by adding strong oxidizing here. Yes? Okay, everyone? Understood? Soda lime decarboxylation, very good. Yes. You can also do that, okay? You can also apply that. Br2NaOH, you can also apply that formula, okay? There are so many ways to converting propanoic acid to ethanoic acid, right? Okay? Yes. Now, next is ethanoic acid to 2-hydroxyethanoic acid. Now, tell me this one. Now, this is easy, right? You have ethanoic acid CH3, COOH. You need to convert it to 2-hydroxy, that means CH2, COOH. Ethanoic acid means OH here, right? So, what you can do? Hoffman-Bromamide reaction. No, not Hoffman-Bromamide reaction. This will be HVZ reaction, right? HVZ reaction, right? Add Br2, NaOH, right? Am I doing wait, by adding this you will get CH2, C alpha hydrogen will be replaced here. Oh, wait. Okay, yes, this is HVZ reaction. Okay. Yes, okay, HVZ reaction. Okay, HVZ Helvo-Haar-Zelinsky reaction. Okay, then convert this and then simply add KOH aqueous medium. Okay, KOH aqueous medium, and here this will be changed to your 2-hydroxyethanoic acid. Right? Okay, everyone? Yes, beta? Okay. Next is ethanoic to methanamine. Ethanoic to methanamine. Everybody, ethanoic to methanamine. Yes, everybody. We're just left with 5 more reactions. Okay, 5 more reactions. Now, ethanoic, that is CH3COH, then converted into methanamine. Okay, this is methanamine. CH2NH2. Right? Okay, now let us see. Decrease the number of carbon here. Okay, decrease the number of carbon here. How you can do this? Okay, there's so many ways. You can convert it into CH3, right? CH4. Then after that, adding something here and convert it into NH2 will be very difficult for you. So let us not apply that here, right? Let us not go to that here, right? Or you can, if you convert this into amide and then do the Hofmann-bromide reaction, that would be easy, right? Okay, that would be much easier, right? Yes, if you can convert it into amide, convert this into amide, right? Then do the Hofmann-bromide reaction. Now, how to convert it into amide? Everyone, how to convert it into amide? If I add PCl5 or PCl3 or SOCl2, anything here, this will be converted into CH3COCl, right? Okay, this will be converted to CH3COCl, right? Now, to this, if I add NH3, that is ammonia. Now here, minus HCl, the hydrogen from here, Cl from here, minus HCl, you will get CH3C double bond O NH2. You can write it here, CH3CO NH2, right? Okay, then doing the Hofmann-bromide reaction here, that is Hofmann-bromamide reaction, right? You will get the 1 degree ammonia. Yes, everybody? Okay? Yes, everyone? Hofmann-bromide reaction. Just 5 minutes more. Okay? Just 5 minutes more is the session here. Okay? Now, next thing is aniline. Okay? This is aniline to para-nitroaniline. Okay? Aniline to para-nitroaniline. So aniline is this one, aniline is this is aniline, converted into para-nitroaniline. So very important, you can't directly do the nitration here. In that way you will have 47% meta, then you will have some para, then you will have just 2% of ortho product. So what you will do here, firstly, we will do the acetylation here by adding the CH3CO twice O in presence of a very strong base as compared to aniline, that is pyridine. You will have, this is NH, this is NH, COCH3. After that, do the nitration here. Do the nitration by adding H2SO4 and HNO3, right? And hence you will have, this is, why this is done? Because otherwise it will form a meta product, right? It will form anilinium ion, right? That is meta directing. So that is why we are doing all these things. We are protecting our meta product. We are protecting the para product. We want to make the para product as a major product. Now you will have NHCOCH3. This is the major product, that is NO2. This is the major product here, right? Okay. Then we will add OH negative or H positive here, and you will get the desired, that is para-nitroaniline. Yes, everyone? Very good. Okay. Next is everyone, last 3 questions here. Now you have para-nitrotoluene. You have para-nitrotoluene. This is nitro group here, right? 2-bromo, very important. 2-bromo benzoic acid. Very important. This involves so many steps here. Okay, this involves actually so many steps here. Okay, this involves so many steps. Everyone, see this very carefully. Okay, this is a long step, right? This actually involves so many steps here. Right, everyone? Yes. Okay, I want all of you to actually give me some hint on this. Para-nitrotoluene 2-bromo benzoic acid. Okay. Now, this CH3 can be converted to COH, right? But we will convert this after some time, right? Firstly, we need to eliminate this bromo and add the NO2 here, right? Okay, and add the NO2 here. So now, firstly, if we do the bromination here, okay, if we do the bromination here, we will get, everyone, what we will get? We will get this one. We'll get this product here. Now, this is a ortho-para directing group, right? Okay, this is ortho-para directing, but para position is not free, so bromine will be added here, and here you will have NO2, right? Okay, now we need to eliminate this NO2 here, right? And then oxidize this. How do we eliminate this NO2? Everybody, we can do disodium with NO2. Yes, very good. We can do the diazotization, right? We can do the diazotization, that is NaNO2, HNO3. Then we have 0 to 5 degrees Celsius, right? Then this will be, here you will have, everybody, this is CH3, this is Br, this is N2Cl, right? Okay, then after this you can add H3PO4 here, right? Then heat it, you will get the benzene here. Okay, this will disappear, and you will get this one. You will get this is CH3, this is Br, right? After that, I just need to oxidize it, okay? Adding KMNO4, right? Okay, understood this? Okay? Yes, but myself more, you know, but minus I effect. No, bacha, no. This is, we are talking about CH3 here, not this one. Okay, we are talking. Wait. This is wait. This is plus I effect here, right? Minus I. Either way you will have this, okay? Either way you will have this, okay? If we talk about the minus M group of, if you talk about the minus M effect of this, even then you will have that only. If you talk about the minus M group, okay, this is minus electron withdrawing. Even in that case, minus M group means it will have, you will have ortho and para positive, right? That is going to be meta directing. So meta position, in comparison to this, meta is this position, right? This is the meta position. I was talking about CH3, okay? Okay, if you talk about NO2, this is the meta position, comparison to this, right? Okay, understood this? Yes, bacha. Keith, understood, bacha? If you talk about the minus I effect here, corresponding to if you talk about NO2, here these are the meta positions, okay? So, if you talk about NO2, it will also, in comparison to NO2 also, it will be substituted on this position, okay? There is no other position left for it, right? Okay? Yes? Perfect. Next we have nitrobenzene to chlorobenzene. You have nitrobenzene, and you have here chlorobenzene, and here you have chlorobenzene. How you will do this? Very simple. Firstly, convert it into disonium salt. Okay, just do the diazotization. Okay, 0 to 5 degrees Celsius, and you will convert it into, this will be converted into this is NO2. Firstly, we have to do the reduction here, right? Firstly, do the reduction, SNHCl, right? Reduction here. Then this will be converted into NH2 here, and this will be converted into NH2 here. Yes, everyone? Understood? Reduction of NO2? Yes. Reduction of NO2, right? Stephen's reaction. Then after that, diazotization, 0 to 5 degrees Celsius. This is disonium salt here, N2Cl. And after that, this is, you can do this either by Gattermann reaction, either by Gattermann reaction, or you can do this by Sandmeyer's reaction. Okay, Sandmeyer's reaction. Sandmeyer's reaction. Here you will use Cu2Cl2HCl, and here you will use copper powder HCl, right? Okay, and you will have chlorobenzene, right everybody? Okay, yes, I know I am cute. Okay, so next is, are you made up of copper and beryllium? Because ma'am, you are so cute. This is ethyl benzene. This is ethyl benzene. Ethyl benzene, you have this one. Now ethyl benzene, that is CH2CH3 converted into meta-nitrobenzoic acid. Meta-nitrobenzoic acid. This is CH. Okay, this is COH and this is meta-nitro-NO2. Again, last question of today. Very simple. Firstly, add KMNO4 here. Any chain here will be converted into COH group. Any chain here will be converted into COH group by addition of KMNO4 in basic medium, and here you will have COOH here, benzoic acid. As you know, this group is meta-directing. This group is meta-directing. This is meta-directing, okay? This is meta-directing. Because this shows minus M effect, okay? This shows minus M effect. This is meta-directing. So directly, what you are going to do? You are going to add here. You are going to add here nitrating mixture, okay? H2SO4 and HNO3, and you will have the nitrating mixture, NO2 positive electrophile, and the electrophilic addition reaction, electrophilic substitution reaction will be here, right? Okay everybody? Yes? Okay. So now bacha, we have completed our today's task. Now there is a special surprise for you. It's a very important special question for you that I have specially made for you. And I want all of you, if you want more questions like that, okay, if you want more conversions like that, okay, specially made by me, then I want all of you to answer that. Write it in the comment section that you have solved that. Bacha, this is the NEET Crash Course 2.0 that is launched by Shreyas sir, Gaurav sir and AP sir. Right, so here bacha, this is English batch. This is English batch which we are launching here. Right, live interactive session starting from 26 February for 2024 students. Right, and this is only for 4,000. This is only for 4,000. Okay, and the quality. You know, if you're providing you such quality lectures free of cost, what will be there in the paid batch, right? That is just for 4,000 sitting at your home, right? Live interaction session, you will have mentorship by me also. You will have your mentorship there, right? And yes, so here you will get so many things here, part test, regular test analysis, and all the things that you get in your regular offline crash course. It is the first thing. Second thing is, bacha, you have preparation. For your preparation, I am giving you some important links that is in the description. First is NEET 2024 treasure box. Here you will get PYQs. Here you will get NEET PYQs. Here you will get CBSE PYQs. Here you will get NCERT questions. Okay, how ma'am we are going to get that? Okay, see this. This is the treasure box. Okay, everybody, this is the treasure box. See this? This is the treasure box. Okay, this is the treasure box that we are talking about. Go to chemistry, physics, biology, anything here, and here you can see. For example, we are talking about the aldehyde ketones, right? You just click on this and you will get everything here. Okay, you will get the everything here. Start the test here. This is a PYQs test. Now, if you want to have CBSE questions of any chapter, click on this and you will have important questions, alcohol, phenol, ethers, your important questions, NCERT questions here, right? If you want to have NEET PYQs, just go to this link, you will have your NEET questions. If you want to have CBSE previous year questions, just click on this link and you will have CBSE previous year questions. All the things are provided to you on this, right? These are all the links. Next is amines notes, everything, PYQs, PDF, PYQs, test, NCERT solution, everything is provided to you, right? Okay. And bacha, next thing bacha, okay, top most question that I was talking to you, okay, most difficult question on this topic, okay. So I have made, if you want, that is like so much, that needs so much efforts to make flowcharts for you, to make big conversions for you. So I want all of you to solve that by yourself, and after that I will give you the answer, right? If you want more such questions specially made by me, right, then you have to write it, yes ma'am, we have solved that, okay. Then you will get the link. I will provide you the link on the Telegram channel itself, right, and on the description also that link will be updated. The solution of that question will be updated, right, and then we will discuss about that solution also, right. But I want all of you to firstly go through that and answer that yourself, so that you can test yourself, okay. Understood everyone? Yes, bacha. And next is for all the students here who want to have scholarship, right? Who are looking for scholarship, right? So, bacha, there is scholarship for you. There is no shame in taking scholarship, right? If you think that you are prepared, you are well prepared, go for it. Go for the test. Do the test, okay? Take the test, and after that, see where you stand. If you are stand somewhere, okay, if you are at a good rank, then we will provide you scholarship, not only for online courses but also for offline courses. If you have any offline center nearby, you can go to that center and give your test. If you don't have any offline center, no worries, you can go give that test at your home and you will get the scholarship, right? Okay everybody, so please give this test, okay. You will get the link in the description box of this test. These are the centers that we have, okay. Understood? Yes bacha, everybody. And this is our Telegram. You can join this Telegram channel. And once more, I'll just show you this IVSAT link here. The last here, that is IVSAT link. You will see here. You will fill the form here. Which exam are you targeting? This is offline or online? What are the classes? Do you want to give the test at Vedantu Learning Center or at your home? Everything, just register that. Okay, everybody? Understood? This is a one-time opportunity. So everybody, please give the IVSAT. There is no harm. There is no harm in giving a test, right? What if you scored well and you have your scholarship? Your parents will be so proud of you because you will be managing your own studies, right? So I want all of you to give that test. Yes? Okay? Perfect. Okay then bacha, bye-bye, take care, see you all on Thursday for biomolecules, and there is some very special surprise for you, specially made by me, for biomolecules chapter. Yes, you're talking about handwritten notes? Yes. Okay, so I was not able to resist that. So I am going to give you my special handwritten notes, okay, for biomolecules. I know the structures are really tough. For that, I am going to give you handwritten notes. So everybody, do join the session on Thursday. So I'll reveal where you will get your handwritten notes for biomolecules. Okay then, bye-bye. Take care, everybody. See you on Thursday at 7 p.m. Okay, see you on Thursday at 7 p.m. Okay then, bye-bye. Take care.